in this tutorial, I'll go through the Vertex Animator plugin that was created for Unreal Engine 5.1 to 5.3 at the moment. So here I already have it enabled. So after enabling, you need to restart the engine. Then you should see this icon up here. And once you open it, you'll see this window. And here you have three options. So to get started, we actually need to create the Vertex animated static mesh. So for that, in this tutorial, I'll use the sample content. So if you press here, it will import those. Here you'll see a few different files that technically you could already start setting up the animations with these. But in this case, I'll use just the skeletal mesh to show you the full progress of this. So let's start by exporting the skeletal mesh. And here I'll just save it as sk factory worker source, just to have a separation there. I'll just disable these options here and export. So the next steps, you can choose if you want to do it with another 3D software. I recommend using Blender because there is also a plugin for that, an add-on actually. The add-on will be listed in the documentation, and yeah, I think the documentation has it. So for that, you go here, install this, and enable it. Next, let's import the FBX. So we go to that same location, tutorial files, sample content, and import it. So the process here is relatively simple. So as you can see, we don't need materials at the moment. The basic idea here is chopping up the model into parts. So let's say if we cut it here, 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 and maybe one cut here, one cut here, one here. Basically all the main joints of the body, because we don't need the fingers and we don't need any other smaller bone. So the idea is to chop the model like this. So let's just disable the annotations. Just a second, I forgot where that was. Well, anyway, let's skip it for now. Okay, so to get that going, in this case, I'll just use Alt-J to try to quadriculate, to make the topology into quads, just to make it easier. But the process here is literally the one mentioned. So you are just going to select, detach, or split if necessary. So for instance here, maybe we can split in this part, and then we detach it. And yeah, this process is a bit tedious, but in the end, I'll just open the other file so we don't waste that much time with this. But what you should have is something like this in the end. Let me just hide the skeleton for now. So if I change here, and yeah, random. So as you can see, you have several different parts. The only extra step I took here was to close the parts. As you can see, it was done pretty quickly, so the mesh is not perfect. But you actually can do, of course, a better job doing that. So that is basically the main part of the process. After that, another step is actually renaming the static meshes. So for that, I recommend using Let me just disable so I can show it. So for that, I recommend selecting the armature, going here to the object and put it in front, just so you know which bone you are seeing. And then here on the skeleton, just enable names. Basically what we need to do is rename the piece to the bone that is here. So as you can see, in this case, I already have all of them renamed. So the head piece has the head bone name. So it's just that on the whole process. Like in this case here, I picked the spine too, because it's more or less in the middle of the piece. But usually for arms and legs, you pick of course, the major bone, and then you just leave the foot. In Blender, that is almost all the required manual work. So after you reach this point, having only the armature and the different split pieces here, and of course enabling the add-on, you see it here. So you have the Vertex Animator tab. This option here is just if you have, let's say you download the skeleton from Mixamo, then you can put here Mixamo rig, and you can remove that string for the names just to make it cleaner. This is just like an extra feature. The main thing here is actually to select the armature that you want to use. In this case, we just have one, so you just select that one and you generate the files. Watch out here. Here now it says generated successfully, meaning everything went correctly. One thing that can go wrong and may go wrong is, let's say that you have a bigger skeleton, let's say something like this, like a giant model, and you try to do the same process. Yeah, actually here it didn't happen, the issue, but let's do it differently then. Let's say you have like a limb that goes a bit longer than usual. Of course, assuming that this is a human scale, and this is just to show the edge cases. Okay, let me try to replicate that issue. So we have this, and we stretch this arm a bit bigger than usual. If you receive this option, object left arm 001 is outside the 1 meter length, you notice that a few pieces until that one will remain in the scene. Basically what that means is that if you enable this collection called bounds preview, let's enable it. Basically each piece can't go beyond these bounds because the shader is limited to this 1 meter bound, meaning that if you do need let's say an arm like this to be exported, the ideal solution would be to actually grayscale the rig. So let's say something like this, and then when you generate the files again, that will be generated successfully because nothing will go out of bounds. So that's just something to keep in mind in case it happens. And yeah, if you want to check what's being exported, in the same file location that you put the Blender file, this one, in the same location there will be 3 files being exported. Yeah, this is actually the source, so let's put it here. So you have a text file, an SK sample blender, SM sample blender, which in this case inherits the name of the file. So the first option you need only in the engine. Yeah, of course, everything will be needed in the engine. The second file is the skeletal mesh. This is just in case you have grayscale the model. So just to make sure that everything fits correctly, it also exports the skeletal mesh, and this is the static mesh. And just so you know how the static mesh should look, I'll just import here. So static mesh, And as you can see, it just looks like a bunch of pieces scattered. For some reason, this shouldn't happen. But yeah, let's see how that will behave in the engine. So yeah, in any case, let's just revert that arm. Yeah. So yeah, basically, if you notice anything weird going on in the engine, it might be because of the bounds. I know that issue might happen because of the scale of the skeleton and the scale of the mesh. So there is this balance that needs to fit correctly. So yeah, just be mindful that these bounds need to be respected. So anything, let's say that that case happens where the arm goes beyond, it means that the part beyond will be animated with the next section of the mesh. So yeah, just to keep that in mind. And yeah, let's just re-export with the correct length of the arm generated successfully. And just to make sure, let's import it again in the engine. Static mesh. Yeah, that's how it should look. No part should go beyond the limits. Yep. So yeah, that one we got ready. So basically, if you don't use Blender, there is a section in the documentation that goes through the exact needs of that. So if you check this one, manually processing the mesh on page 6, you actually see all the changes that the plugin, that the add-on does. So you can just follow these. In this case, just to keep it short as well, I'll just explain the Blender workflow. So yeah, the Blender part is done. So the next step is, let's just create a new folder. So a new folder here. And here, sample content. Okay, let's import the skeletal mesh. I'll just create a new skeleton. I do not want materials now. And yeah, so this is the skeletal mesh. Now I'll import the static mesh. No materials as well. Yep. Another check that is important to do is actually dragging both to the scene just to see if the scale is correct. And this is a very important step, because if they don't match, it doesn't need to be exactly matching. Just make sure that it's not like that. This is not like this. Oops. If it's something like this, you should probably either edit this one or edit the skeletal mesh, but basically the sizes should be consistent. And also another thing that we will need is actual animations. So for that, in this case, I'll just use Mixamo. Let's just go there. Just log in here. The animation can also be thrown inside the engine if you want to do retargeting from an asset package to your to this skeleton. That's also doable. So in this case, let's just wait. Yeah, of course you need to upload the character. So let's pick it here. Sample content. Let's upload the sk_sample blender. Let's just wait a little bit. Yeah, so it should automatically detect your rig. So let's just hit next, and let's look for a dance just to actually test it. Let's say, I don't know, this one. Yeah, so yeah, I think that's a good one. We don't need the skin, so let's just without the skin. The skin meaning the actual mesh, so only the animation will be exported, and that's everything we actually need. So I'll just put anim dance 01. Yep. So after that, we do the importing. We make sure that the skeleton is correct. So this skeleton here. Yep. And yeah, one thing to make sure also is that, yeah, the sample rate, just to make sure, set it to 30, because sometimes mix-em animations come with like higher sampling rate, and that can take a long time. So you may notice that some of the animations have this issue of the rotation, so you just come here to the import rotation, type 90 on the x-axis, and re-import animation. So that should be, yep, that's correct now. Again, let's just make sure that, yeah, the sizes are consistent. That can also happen sometimes, that the animation and the actual skeletal mesh have different sizes. So yeah, let's go to the actual plugin now. So this is the interface, and in this case, let's create a new rig. So you open that. In this case, let's call it factory worker, which was the original name of this mesh. You drag the static mesh here, skeletal mesh here. This bone order is the text file that was exported, so you just need to open it, select everything, copy, and paste here. Basically, this is the order of the elements that you have exported, meaning that if you notice here, like it starts from the head, then hips, then left arm, left foot, and so on. So this is literally the sequence of the parts, and they have the exact name of the bone as well, and that's really important to make sure it's correct in case you do the manual workflow. And yeah, let's just create the rig. Let me delete that one. And you'll notice that in the center of your scene there will be a replica of the static mesh, and that's mostly for previewing purposes. So in this case, let's start making some animations. So this section is meant to create animations. As soon as you drag the animation in, you'll see that the name will change, also the FPS may change. I think the default is 15 if I'm not mistaken. You can give whatever name here, so I'll just keep the default. So anim underscore dance 1, add animation, and it will clear again. So in theory you can just create another one and so on. So yeah, you also notice that there is this blue button saying the name of the animation, pending bake. Basically what that does when you press is literally baking the animation. So let's do it now. So you see a process and the preview of the animation here. And once that's done, you will be taken to a folder where that animation is saved. Let's see. Yep, so this is the exported assets. There is a blueprint just for previewing purposes, so it already has the material assigned to the static mesh and everything. If you check the assets folder, you'll see the material and the baked information here. You also have the animation asset here. You don't need to change anything inside, and I honestly don't recommend changing anything because it may affect the animations. And also under the name of the factory worker, which was the name of the rig, you'll see the rig file, and the source is basically the static mesh, so you kind of contain things inside here. In the assets folder, you also notice this is the master material. It's a copy of the one from the plugin, so you can freely change this. And this is the current animation, the current material. So here you can do whatever you want. The only thing that you need is this part here of the material. And if you create an animation from that, if you create an instance like this, the only thing you need to change is actually this. So you need to assign the animation data and the animation settings in these ones. And you have these other parameters, which you can test for yourself. And yeah, that's pretty much the baking part. So technically you could already use this. You'll notice that the materials are white, but it's just a matter of actually assigning the correct material. So if I go here and apply here, you'll see that, yeah, it's there. So it basically works that way. You also notice a few extra options here. The first one being the bounds editing. Because one of the problems with these type of animations is this. As you can see, the model disappears when I tilt the camera, and that's because the bounds are actually these. So the model looks different, but the bounds of the objects are like this. So when the camera goes outside that, the model just goes out. And that's why you need to change and fix the bounds for that. So you just enable preview here, press G. The green box is representing these values, which is like a recommended bounds, and the red one is the current bounds. So technically when the camera goes, when the red part goes out of the camera, the model disappears, and that's how bounds work. So what we want is, in this case, let's just apply the green one. So you can use the default values here and just apply new bounds. So in this part here, as you can see now, the bounds are correct. I don't know what happened, but basically now you can actually see the whole character and it doesn't disappear unless you actually go with the camera out of those bounds. And yeah, that's the desired behavior. You can also reset the bounds, and yeah, either reset, apply new bounds. You can copy from a static mesh. So let's say you want to use these exact bounds, you can just pick here, apply the bounds, and yeah. So yeah, that's pretty much that. And the next thing is the optimization method. So the optimization method basically means if you want to use LODs or Nanite. Nanite doesn't seem to work that well with world position offset, so I recommend using LODs. Here you can basically apply the same profiles from the static mesh editor. So in this case, I'll just put the high detail one. Usually it's pretty okay, and that should apply to the static mesh. And yeah, that's pretty much the workflow. So you adjust the mesh, you import the files here, and then you may ask what's the main advantage of this technique over using actual skeletal meshes. So I actually put together this small demo. You can also download this from the marketplace page and also in the documentation. If you check the end of the documentation here, you'll see there are a few links, so you can actually just check those. This is the link, so it's a builded project. Let me just open that. I'll just close this because my laptop is not the best. So I'll just open this, and this is basically a stress test project. So as you can see here, it's using the Vertex Animator and LODs. So let's just expand the count. So let's see how far I can go. Expand. So at the moment we have 1,700. Yeah, let's put a few more. Yeah, so maybe 2,300 instances. As you can see, the FPS is not ideal, but keep in mind that my laptop has a 2070, so it's kind of oldish model. But let's compare to Skeletal Meshes plus LODs, which they are using exactly the same profile, so meaning the same reduction. So let's see the difference, 25 to 30. And if I put LODs, you can see that it decreases. The main advantage is usually for big crowds because it doesn't actually affect that much the performance. If you put in a better computer, you can go up to, I don't know, 10,000 characters like this, and you can easily just swap. And if you want to randomize animations, like having multiple animations, you can also do that. And usually it doesn't affect performance that much. The main factor here might actually be the static meshes, the poly count of the scene. So yeah, technically you can try to go further to see how your computer behaves. And yeah, if you like it, just go for it. This project is basically meant for you to compare the results and see for yourself if this is good enough. As you can see, the only downside is the character is actually kind of chopped up, but depending on the output and the distance that you need to see them, it actually looks quite good. So yeah, like you can build huge crowds without affecting that much the performance. And yeah, that's it. Yeah, thanks for watching, and yep, have fun.